Hello students, in today's lecture we are going to discuss Cauchy-Euler's homogeneous linear differential equation. So before starting this we must know that linear differential equation with constant coefficient which is given as dn y of dx of n plus k1 dn minus 1 y of d of x minus 1 plus k2 dn minus 2 y of d of x n minus 2 and so on plus kn of y is equal to function of x. This is linear differential equation with constant coefficient. If suppose it does not have constant coefficient and it is type of variable coefficient, we can say it is Cauchy-Euler's homogeneous equation. So the standard type of this equation will be as, suppose that we have x of n dn of y d of xn plus k1 xn minus 1 d of n minus 1 y of dxn minus 1 and so on kn minus 1 x of dy by dx plus kn of y equal to some function of x. So suppose that we have given this type of equation. So what we observe here, we observe there the value of what we observe that here the extra term of xn minus 1 and x is coming, which were absent in the constant coefficient term. So it is Cauchy-Euler homogeneous linear differential equation. So our aim is to convert this equation into this form, and after converting this form we can easily solve it. So what is the procedure? Let's check it out. So suppose that we have given such type of equations. So here k1 k2 kn etc are constant. These are constants. So what is the procedure? So what we do, we basically do we consider let x is equal to exponential z. So z is equal to nothing, it is a log of x. So dz by dx will be 1 by x. So basically we are changing the independent variable. X will be converted to z. How it is possible? Let's check. So we'll write dy by dx as dy by dz by dx. So dz by dx is what? Dz by dx is 1 by x. So we write dz by dx here. So it will be 1 upon x of dy by dz. So you observe that here independent variable x is converted into z. So it will be x of dy by dx is equal to dy by dz, or it can be written as x of d by dx stand for d, or in general we can say that x dy by dx is equal to d of y. So this is our conversion. We should remember in every question we will convert x dy by dx in the form of d of y. So x dy by dx will be converted in form of dy. Suppose that we have second order, so d2y by dx square will be changed as d by dx and dy by dx. So dy by dx, you have already find out dy by dx, so you will put here dy by dx and your dy by dx is, so what will you write here? This is dy by dx. Dy by dx is 1 upon x dy by dz. This is, so after getting derivative we get minus 1 upon x square dy by dz by u dot v formula, plus 1 upon x of d2y by dx square dot dz by dx. And what is dz by dx? Dz by dx is 1 by x, so it will be written as minus 1 upon x square dy by dz plus 1 upon x square d2y by dx square, sorry, it will be dz square, so it will be dz square. So what you get? You get d2y by dx square is equal to minus 1 upon x square plus 1 upon x square, this is dy by dz plus 1 upon x square d2y by dz square. So it will be d2y by dx square is equal to 1 upon x square is common, so you can write is d2y by dz square minus dy by dz. So you can write as 1 upon x square d2 minus d of y, or in another way you can write x square d2y by dx square, so it will be d minus 1 of y. So you are to remember, whenever you have given x square d2y by dx square, you just need to write d minus 1 y. So similarly you can get x cube dqy by dx cube as d minus 1 d minus 2y. So it is the basic procedure. So when you put all this value in equation 1, in equation 2, so you will get equation 1. So our Cauchy-Euler homogeneous equation is converted into the form of linear differential equation with constant coefficient, and after putting these value the solution will be easy, as we have discussed in the earlier lecture. So for understanding this methodology, let's take one example. Suppose that we have given one question in the examination. We have given solve x square d2y by dx square plus 3 of x, sorry, the question is x square dqy by dx cube plus 3x d2y by dx square plus dy by dx is equal to x square log of x. It is given questions. So first we need to check it is homogeneous in the form of term. So we observe that here term is x square and derivative is dqy by dx cube. So this term should be x cube, because we have already mentioned that it should be dny of d of xn. So n must be same for derivative as well as the variable coefficient. So what we do, if suppose that if we are not given in the form of homogeneity, So we multiply this whole equation with x, so it will be converted as x cube dqy by dx cube plus 3x square d2y by dx square plus x of dy by dx is equal to x cube log of x. So now this is Cauchy's homogeneous linear equations with variable coefficient. So now the solution of this equation can be written as let x is equal to exponential z. So x is equal to exponential z, so z is equal to log of x. Therefore derivative dz by dx will be 1 by x. Okay, and now the term of x cube dqy by dx cube can be written as d minus 1 d minus 2 of y. Similarly, term of x square d2y by dx square can be written as d minus 1, and term of x dy by dx can be written as d of y. So putting all these values in relation 1, we get d minus 1 d minus 2 plus 3d d minus 1 plus d of y is equal to x cube. So x cube means exponential 3z and log x means z. So the after so we can say that here we have to solve this term completely. So it will be, so what will be d minus 1 d minus 2. So after solving, what we get basically, so let's solve it. This will be d square minus d minus 2 plus 3d square minus 3d plus d of y is equal to exponential 3z into z, where d stand for d by dz. So now further solving, we get d square d minus 2 minus d minus 2 plus 3d square minus 2d into y is equal to z of exponential 3z. So what will be d cube minus 2d square minus d square plus 2d plus 3d square minus 2d of y equal to z exponential 3z. So what we get? We get here 2d square minus d square, that is minus 3d square, will cancel out, plus 3d square, and this 2d will be cancel out. This 2d will be cancel out with plus of 2d. So here what we get? We get only d cube. So we get here d cube of y is equal to z of exponential 3z. This is relation number 2. So for auxiliary equation, we write m cube equal to 0, which provide m equal to 0, 0, 0. That means 3 equal roots. Therefore complementary function CF will be C1 plus C2 z plus C3 z square exponential 0 dot of, we can say, So what we get basically, remember that whenever you have dy by dx, so you write, suppose that you have two real roots, actually two repeated real roots. Suppose that m1 is equal to 2 and m2 is equal to 2. So how do you write? You write c1 plus c2 x of exponential 2 of exponential of 2 of x. So basically this methodology is used here. So you get c1 exponential z plus c3 exponential c3 into z square. So it is your cf. So it is number equation third. Suppose because we have used equation number 2 already, so it is cf. So now our aim is to find the pi. So pi will be 1 upon d cube of z exponential 3z. So it will be exponential 3z upon d plus 3 cube of z. So exponential 3z upon, so how we will use, actually basically we take it out 3 cube common, so it will be 1 plus d by 3 cube of z. So it will be exponential 3z upon 27, and it will be go outside upper side, so it will be 1 plus d by 3 minus 3 of z. So you observe that the value the power of z is 1, so it will be expand only up to 1 terms. So it will be exponential 3z upon 27 1 minus 3d by 3 of z. So it will be exponential 3z upon 27 1 minus d of z. So now operating z with the bracket, we get exponential 3z upon 27 z minus 1, because dz is equal to 1. So you get z minus 1. So what is your complete solution? This is your pi. So this is your particular integral basically. So what will be your pi? Your complete solution will be complete solution cf plus pi. So your CF was c1 plus c2z plus c3z square plus pi is exponential 3 of z upon 27 z minus 1. So it is your answer, but again you need to convert z into x. So what you have, z is equal to, you have x is equal to exponential z. So z is equal to log of x. So you need to put z equal to log of x. So every term of z will be converted into the form of log of x. So your pi in term of y, your complete solution in term of x and y will be c1 plus c2, and z means log of x, plus c3 z square means log of x square, plus exponential 3z means x cube upon 27, and z means log of x minus x. So complete solution in term of y and x is equal to, y is equal to c1 plus c2 log of x plus c3 log of x square plus x cube 27 log of x minus x cube 27. This is your complete answer. So our aim was to convert the Cauchy's homogeneous linear equation into the form of linear differential equation with constant coefficient. So it is the only procedure. You just remember that your independent variable x must be converted into the Z, and after converting it you can solve it with the help of linear differential equation with constant coefficient methods. So I hope you understand this methodology. So our new lecture will be also be related to the same methodology. So please keep watching, like, subscribe our YouTube channel and share among other students. Thank you very much for watching this video.